Assalamu alaikum. In this video, we'll continue by calculating the equilibrium concentrations and pressure concentration by using the ICE table, but this would be part 2. Okay, we did already part 1, and in part 1, we discussed how to calculate or using the ICE to calculate the equilibrium concentration if you have only initial concentration and one concentration at equilibrium. But in this video, we'll do different method here. Let's see. For this one, you have a chemical reaction to HI will give I2 plus IH2. If we started by putting 0.01 molar of HI and I2, so for both concentrations, we would use 0.01. And we will add this one to 0.096 molar of HI. So we will have a beaker, and inside this beaker, we'll put 0.01 of H2, 0.01 of I2, and 0.096 of HI. First, do we have an equilibrium or not? We can't tell till this point because we need more information. So what we're going to give us, if the value of the equilibrium constant is equal to K is equal to 0.016, calculate the equilibrium concentration of all the substances. Okay, so first, the difference between this question and the question we did in part 1. In part 1, you always give you a concentration at equilibrium. So you will giving always one concentration for one substance at equilibrium. And he didn't give you the K because he will ask you to calculate the K. But here you are given the K and you don't have any concentration at equilibrium. So what we're going to do first, we need to use the concentration at the initial concentration. To use the initial concentration, we will calculate the quotient, which is equal to the K in the expression, but different values. So for this one, it will be products over reactant. So we have two products and we have one reactant. We'll use the initial concentration to calculate the Q. So it will be 0.01 times 0.01 over 0.096 to the power of 2, and this will give you 0.011. Okay, so this is the value for Q. Now we need to compare this value to K. K is 0.016. What is the relation between this one? We'll figure out that this Q is less than K. Okay, so if Q is less than K, so the reaction is not at equilibrium, and this reaction need to be shifted to right or left to reach the equilibrium. So to determine which side the reaction will be shifted to right or left, we can use two methods. First, if you have, this is the quotient here, which is 0.0, which is less than K, so you need to increase the value for this fraction. To increase the value for this fraction, you need to increase the product. So we need to increase product and reduce reactant. So we need to reduce this one and increase. So increase product and reduce reaction. So we need to shift right. So if you shift right, you will increase the product and reduce the reactant. This is one part. And the other, you can see where is the mouth for the sign. This sign, so this sign is directed to the right. So we will shift to right. Okay, so we know that this reaction will shift to right. Now we can start by using the ICE. Because the right side, the reaction shifted to, it will give you exactly the change. It will be positive or negative for both or for one only. Okay, so this is ICE, this is HI, this is H2, this is I2. What are the initial concentration? Let's put the initial concentration here. For this one, 0.096, 0.01, 0.01. Okay, let's come for the change. This is the most important part here. So we decided that the reaction will shift to right. It means the product will increase and the reactant decrease. It means the change in the reactant will be a negative and for products will be a positive one. And of course, we'll use the coefficient from the equation. So that's what will be minus 2x. This one has one coefficient of 1, so it will be x, and this will be x. When we adding these two concentrations, we will reach to the concentration at equilibrium. So this will be 0.96 minus 2x, 0.01 plus x, and 0.01 plus x. This will be the concentration at equilibrium. Okay, by using these concentrations, we can find the value for K. So it will be 0.01 plus x times 0.01 plus x, because we have two products here over one reactant, 0.096 minus 2x to the power of 2. Now we will put the value for K and we will solve this equation. So we have 0.016 equal to 0.01 plus x times 0.01 plus x over 0.096 minus 2x to the power of 2. Okay, because this bracket is the same, so I will just put the brackets once and put the exponent 2. Okay, minus 2x equals to 0.016. Now I will take the square root to remove this exponent, and okay, so it will be 0.01 plus x over 0.096 minus 2x equals to this value, the square root with 0.126. Now we need to solve this equation. So multiply these two, and this will be multiplied. So 0.096 will multiplied by 0.126, which is 0.0121 minus 2x will multiplied by 0.126, and this will give you 0.252x equal to these two multiplied with 1, so 0.01 plus x. Now we will solve the equation, so this x will go for the other side, and this value will come here, and by doing this, we'll find the value for x, which is equal to 0.0017. Okay, now this is the value for x. We need to calculate the concentration at equilibrium. We know that we started with, let's go for this one. This is the concentration at equilibrium for HI, it's 0.096 minus 2x. For H2, it's 0.101 plus x, and the same for I2. So these two will have the same concentration, but HI will have different concentration. So we'll go here and substitute for them. So H2 and I2 have the same value. It will be 0.01 plus 6, because here they have the same value. This is a concentration at equilibrium, so 0.01 plus 0.0017, so it will be 0.0117 molar. Okay, the concentration of I2 will be equal to this. We'll take this value and substitute for it. So it will be 0.096 minus 2 times x, which is 0.0017. This will give you 0.0926 molar. Okay, one more example here. So we have different example again, the same thing. Okay, we have a reaction, the same reaction, but we will start with different initial concentrations. So the concentration of HI and H2 and I2 will be 0.1. Concentration for HI is 0.01. Okay, and again, we have the K value, and we don't have any concentration at equilibrium. So what is the difference again here? For this one, you have all the initial concentrations will be given. You will give the value for K, and you don't have any concentration at equilibrium. So you need to decide how to find the equilibrium concentration. So you need to decide to which side this reaction will shift. It will shift to form more products or more reactant. And this will be decided from the value for the quotient Q. So we'll find the value for Q, which is H2 times I2 over HI. So you can't go for the I stable directly, because for the I stable, you need to decide if which one will be a negative change, which one will be a positive change. That's why we need to start with the Q. But if you're given one substance with an equilibrium concentration, at least one, so from this one, you can find the change and apply it for the other substances. Okay, so we'll substitute here for the initial concentration, and this will give you 100. Oh, so the Q is 100, but the K is 0.01. Okay, so Q is higher. Okay, again, from the sign, the direction for this sign, we can see that the mouse for this sign is to the left. So we should shift to the left. Okay, let's see. This value is higher than K, so we need to decrease this value. To decrease this value means we need to decrease this one and increase this one. So the products will decrease and the reactant will increase. Okay, now we know the change, how the change will happen for the reactants and products. So we can now start with the I stable. Okay, I need one more here. Okay, this is HI, H2, I2. Okay, the initial concentration 0.01 0.1, 0.1. The change, we decided that the change for reactants will be positive, for products will be a negative. And again, this will be decided from to which side this reaction will shift. It will be shifted to right or left. It will shift to make more products or more reactants. Here, this reaction needs more reactants. That's why it will shift to left. It will be plus 2x and x and x. And again, this 2x from the coefficient from the equation. Okay, by adding these two, we will reach that to the equilibrium concentration minus x, 0.1 minus x. Now we can put this equilibrium concentration in the K expression. So K equals to 0.1 minus x times 0.1 minus x over 0.01 plus 2x to the power of 2. And we know that K is equal to 0.016. And we will solve it as we did before. So I will put 0.1 minus x to the power of 2 over 0.01 plus 2x to the power of 2 equal to 0.016. And then I will take the square root to remove the square here. So it will be 0.1 minus x over 0.01 plus 2x equal to 0.0121. And then we will solve the equation. These will be multiplied by 2 and this side will be multiplied by each other. And we can solve the equation. So it will be 1.2 times 10 to the negative 4. These 2 multiplied plus 0.0242x equals to 0.1 minus x. And then we will send the x to this side and we will send this number to this side and change the sign. And we can solve for x, and x will be equals to 0.0975. Now, if we have the x, we can find the concentration for all the substance for H2O2, which is equal to I2, because we know that both are equal. Okay, and from HI, for HI. For H2 and I2, it's 0.1 minus x. It means it's 0.1 minus 0.0975. So the concentration or the equilibrium concentration for this one will be equal to 2.5 times 10 to the negative 3 molar. Okay, for this one, it's 0.01 plus 2x, and the x is 0.0975. Okay, and this will be equals to 0.205 molar.